Now we'll discuss the question number 33, and it is from casting. And the question is, for sand casting a steel with dimension 80 mm into 120 mm into 20 mm, a cylindrical riser has to be designed. So for a steel plate, we have to design a cylindrical riser. The height of the riser is equal to its diameter. It is given. The total solidification time for the casting is 2 minutes. Now in that Chaudinov's law, for the estimation of that total solidification time, exponent is to be taken as 2. And for a solidification time of 3 minutes in the riser, the diameter of the riser is. So generally we have to find out the diameter of the riser here. So solidification time of casting and solidification time of that riser, it is given. So we'll see. So we have to do a steel casting, that a casting of a steel having its dimension 80 mm into 120 mm into 20 mm. Now for that steel plate, we have to design a that cylindrical riser, and it is given that diameter is equal to h for that riser. Now that total solidification time for the casting is 2 minutes. So that solidification time for casting, it is 2 minutes, and solidification time of that riser, which is equal to 3 minutes. And exponent is 2. So by using that Chaudinov's rule, we know that solidification time, which is equal to that mold constant or solidification factor into volume upon that surface area, which is exposed to heat transfer to the power 2, which is the exponent which is given here. So what we will do is, so for riser, that for casting we know its solidification time is 2 minutes. So I can write that for casting, so solidification time of that casting, which is equal to mold constant and into that volume of casting upon that surface area of the casting. So solidification time, it is given 2 minutes. So 2, which is equal to that cm, we don't know the value of that mold constant, into its volume. Volume of the casting will be 80 into 120 into 20 upon its surface area will be 2 into this 80 into 120 plus 120 into 20 plus 20 into 80. So this will be your volume upon surface area of the casting. Now if you will solve this, you will get this mold constant, which is equal to 0.04. So this is the value of the mold constant. Now for riser, we know this solidification time of riser, which is equal to that mold constant into volume upon the surface area, which is exposed to heat transfer of that riser to the power 2. So this V upon that AS, we also know it is called that modulus. So for for cylindrical riser, if you will find out the volume upon that surface area, you will get d by 6 for that cylindrical riser, for that side cylindrical riser. So solidification time for riser, it is 3 minutes, which is equal to that mold constant we got, it is 0.04 into d upon 6 to the power 2. So d upon 6, which is equal to 3 upon 0.04 to the power 1 by 2. So this one, 3 upon 0.04 to the power 0.5, it is equal to 8.66. Now if you multiply 6 by that 8.66, you will get d equal to 51.96 mm. So this will be your diameter of that riser for cylindrical riser. So in this way we can find out the diameter once we have the dimension of the casting, and as you know it is cylindrical riser whose diameter equal to height.